Alright, continuing on with our projectile motion problem that I started in the last video, we're now going to take a look at the second part of our question over here, which we say at what height was the rocket launched? Well, there are two ways to look at this answer, or this question. Number one, you can know how to tell from a standard form of a quadratic equation what the launching height is by knowing that the launch height, or the height from which the projectile was put into motion, is the constant value. Or you can look at it as time t is got to be equal to 0 to tell you what that is. And this, of course, is the y-intercept. So the constant in, of course, standard form, because if it's in the vertex form, it's not going to be the constant, because that constant isn't really the constant. So that's how we can answer the question B. So if I just look at this formula, I know that the height at which the rocket was launched is 0 because the y-intercept is 0. But there's also, we would also want to say what is h of 0. That's another way of doing the same thing. So this is negative 16 times 0 squared plus 100 times 0. And that, of course, is going to give us a big fat 0, and those are in feet because we're told that the velocity is 100 feet per second. So we know that this height is in feet as well. Now, I had written this formula a little bit differently than it's shown over here. Remember, I had written it as a function, a height as a function of t in this manner here before we got started on part A. Now, you have a question of your own to give a try. It says an object is thrown upward off a building that is 80 feet tall. The following quadratic describes the height at time t. h of t is equal to negative 16t squared plus 64t plus 80. How long before the object hits the ground? How tall is the building? And now, another thing that I would like you to be able to do is to be able to answer the second question in two different ways. And also, I'd like you to be able to tell me what the 64 actually refers to in this equation. So go ahead and pause your video and see if you can tell me all of the answers to these questions and maybe even the ones that I asked verbally. Alright, hopefully you've given this a shot on your own. So our first question says how long before the object hits the ground? Well, it will hit the ground right here. So it's launched from this position at the top of the building, it comes up, then it goes down, and we want to know when it hits the ground, which is when the height is equal to 0. So what we're doing is we're solving the quadratic. 0 is equal to negative 16t squared plus 64t, and then plus 80. So one thing that I would like to know is, can I factor out a GCF? Because I'm going to solve this using factoring. So negative 16, I need to know if I can factor that out of 80. So if I divide 80 by 16, I'm going to get 5. So yes, it's going to be a GCF that I can factor out of here, which will leave me with a positive, because remember, I'm going to take a negative out if at all possible. The leading coefficient is a negative. I want to take it out. So I'll get a positive t squared. I'll get a negative 4t, because 16 will go into 64 4 times. And then I will get a negative 5. And then I want to factor this polynomial right here. So that polynomial right there, I'm going to have negative 16 times 2 binomials. The leading coefficient is 1, so I know that each of these are just going to be a t, and I want the factors of 5 that give me a difference of a negative 4. So 5 and 1 give me that difference of 4, and I need a negative 5 and a positive 1. And so now I will set each of these factors that contain a t. Remember to say negative 16 does not contain a t, so I don't set it equal to 0. And so I have these two options. And this time around, this one over here, the t plus 1, is going to give me a negative 1. That is what we call an extraneous root. So this one doesn't make any sense. It's accounting for this right here, the fact that it was at negative 1 seconds before it was at this height, which doesn't make any sense to us. So we don't care about it. And then this one, I'm going to add 5 to both sides so that I get t is equal to 5. And that is 5 seconds. So this time right here that it hits the ground is after 5 seconds. And again, I know that this is seconds because it says that we have feet and gravity is in a negative 16, and that's feet per second per second. Now, the next question says, how tall is the building? Well, this building's height is how high off the ground it is when it starts, right? So this, when time equals 0, is equal to my height of 0, and that's the building's height. So what that is my y-intercept. And when a function is in standard form like this, my y-intercept is going to be my constant. So I can simply look at my constant in standard form, which my equation thankfully is in standard form. So I can just look at the constant, or I could say, oh, well, I need to find h of 0. And in this case, h of 0 is going to be negative 16 times 0 squared plus 64 times 0, and then my plus are 80. And you'll see these go away, and we simply get that constant, and we know that's in feet because we've told the building was 80 feet. And again, that's how high the building is. Now that's not a mystery because it tells us. So we're just confirming what we already know. Now that's because I want to make sure that you recognize these two things being related to one another. Now this one, the 64, I also asked you to tell me what that meant. So remember that 64 is the velocity at which the projectile was launched. So 64 feet per second is the velocity of the, let's see, object when it was thrown. So that's how fast it was initially thrown off the building. Now, you may get questions of, was the object thrown up or was it thrown down? Well, you could tell if it was thrown up by finding out what the maximum was, right? If you find out this maximum is higher than this height of this building, you know the object was thrown up. If the maximum is actually at building height, then you know the thing was thrown down. So that's that question that may come up of was the object thrown up or not. And that concludes the projectile motion problems. And last but not least, what we have is modeling using quadratic equations. And we can do this in one of two ways. We can do it by hand, or we can do it by using a calculator. It's pretty hard for me to show you with a calculator on my computer because, unfortunately, my computer, I do not have an emulator for my calculator. And by hand, we can certainly do that. So I will do in one last video how we can actually do the by the hand model. So that'll be one more video.